Welcome to chapter 4. We are going to be discussing discrete random variables. So let's start with what a discrete probability distribution function is, right? Probability distribution function, or PDF, probability distribution function. It has two main characteristics, right? This is going to be the way in which your function is distributed. It's going to entail a piece of information, a characteristic, a numerical characteristic that describes your data, accompanied by the probability of that value occurring. So all of those probabilities have to be between 0 and 1. That is a general rule for probability for us. And then also within your chart, or however your function is displayed, you have to contain all possibilities, meaning that if I add all of the probabilities together, we get 1 or 100% of the outcomes being represented there. All right, so like I mentioned, we're going to use a table, typically 2 columns, one with the random variable x and one with its corresponding probability. So let's go ahead and just scroll down and go into the first example. All right, suppose Nancy has classes 3 days a week. She attends classes all 3 days, 80% of the time. She attends 2 days, 15% of the time. She attends 1 day or 1 class 4% of the time, and then no classes 1% of the time. Suppose 1 week is randomly selected. We're going to create this table below that follows all of these pieces. Okay, so in this case, our random variable is talking about the number of times Nancy attends class in a week. It could be up to 3, and ask yourself, what's the smallest amount that she could possibly attend? So I'll write here, what values can the random variable x take on? The random variable x for us is the number of times she attends class. Meaning that these x's we're seeing here could be 0. She didn't attend it at all the way until 3, she attended every day of the week and anything in between. So the random variable she could attend, x could be 0, 1, 2, or 3. Any of those values. So we put those into our table, 0, 1, 2, and 3. And we really like to order these smallest to largest. It just helps the information be stored a little more neatly and helps us be able to find corresponding values easier. All right, so what was the probability she attended 0 times? This is also a new notation I'm going to show you. You don't have to write it this way every time, but here you see this is the random variable x, and this is the probability of x occurring. So if we say the probability that x is 0, see how inside the parentheses I'm saying x is equal to 0. This means the probability of it being exactly 0. And the reason this is an important thing to kind of look at and address is because if we wrote something like p of x being greater than 0, that's 1, 2, or 3, all of those values. Whereas here, p of x equals 0 means we want the probability that she did not attend class at all. Right? Again, just a little intro. So p of x equaling 0 is equal to 1%, right? She attended no classes 1% of the time, or 0.01. All right, what was the probability that x was equal to 1, meaning that she attended class exactly 1 time in the week? 4% of the time, right? 4% of the time, so 0.04. All right, what's the probability that she attended class twice, exactly 2 times in a week? 15% of the time, so 0.15. And the probability that she attended class all 3 times is 0.80. So again, you can make the note, all of these are between 0 and 1, 0.01, 0.04, 0.15, 0.8. And if I add them all together, these guys are 0.95, 0.99, and 1.00 if I added them all together.